So we're going to take a look at section 8.4, which is special products. If we keep in mind when we did section 8.3, we just did something like this, where we had x minus 2, x plus 5, and we just did extended, what I called extended distribution, where we did x times x, so it would be x squared, then x times 5, which would be plus 5x. Then we had our negative 2 times x and negative 2 times 5 right there. We would combine like terms and we'd see we get plus 3x minus 10. Okay, that's pretty much the same idea we're going with right here. Keep those rules in mind. All right, so when we see an n plus 9 and then we have the squared, that squared really just means we're going to write it 2 times. So when you see something squared, just write it another time. So if we have n times n now, same rules apply as in this problem I just did. So we have n times n, we get n squared. Now n times 9 is 9n. 9 times n, another 9n, and then 9 times 9 is 9 squared, or 81. Combine those like terms right here and right here. So we get n squared plus, what's 9 plus 9? Well, we get 18n plus 81 right there. All right. So again, same rules apply from 8.3. Extended distribution is really just distributing two things, one right after another. Now we can see we have an example like this. Go ahead and pause it and then try it yourself. You might see something interesting before I start to talk about it. Okay, we have we can even try just extended distribution again, and I'm going to give you a shortcut here, but let's try this first. So we're going to do b times b. We're going to get b squared. B times negative 6 is, well, b times negative 6 is going to be negative 6b, and then now we have 6 times b, or 6b, and now 6 times negative 6, which is really 6 squared, and we're going to get negative 36. So go ahead and combine like terms. Well, we see that we have opposites here, so that's going to cancel with that, and we are left with b squared minus 36. So here's where the shortcut comes into play. You see in our original problem, we had a b here and a 6 here. Well, what is b squared? B squared is, well, b squared. What is 6 squared? Well, it's 36. So that's our shortcut. You see, you just take each term in your original problem. If this is the same, if this right here is the same with that right there, and if this is the same, and the only thing that's different is the sign here and the sign there. If those are opposites, we can use this shortcut. So we're going to see we have a b here and a b here and a b here. So that's going to be just b squared. And then if we have a 6 here, we just square that and get 36. So if you want to see a different example, we could do x plus 7, x minus 7 right there. Just do the shortcut. You don't even have to do distribution. Well, what's x squared? That's going to be, well, x squared. What's 7 squared? That's going to be 49. And if you have something like this, you're always going to be subtracting it. And that those middle terms are always going to cancel out. Okay. So for number 3, this one really isn't much different than the ones we've been doing. The only thing that is different is just that we have 2 variables. So let's just go ahead. Since we see it's squared, we're going to do 6n plus 4p, and we're going to do that twice. Okay, so go ahead and do extended distribution. 6n times 6n is going to be 36n squared. Now 6n times 4p, we're going to get 24np. Let's go ahead and move on. 4p times 6n, same thing, 24np. And then 4p times 4p is just 4 squared, which is 16, and then p squared, we get that. Combine your like terms. Actually, before we do that, you'll notice that this and this will always be the same if you have something that is squared. So that's always something to look for. Okay, so go ahead and combine your like terms. 36n squared, and then we combine these because those variables are the same. np, so those are the same. we get 48 in P, and just carry that 16P squared down, and we're good to go. So these are all just about recognizing patterns and developing shortcuts. So I want you to do that for these problems right here. Go ahead and try these problems first on your own notes, and then you can go to Canvas, Modules, and then 8.4. But first, again, I want you to try them before you check the solutions.